Greetings, Saintsmen. This is the geometry lesson for lesson 3.4, where we're going to do some proofs with perpendicular lines. First thing we're actually going to tackle is regarding finding distance between a line and a point. Now, the shortest distance between those two is going to be the perpendicular distance, okay? And we're actually just going to jump right into that. If I have a point that is not on this line, right? And we're going to call this line AB, for example. The shortest point there is going to be perpendicular. Anything greater than that is going to be a longer line, and there's actually there's a theorem that we're going to utilize with triangles that's going to help us actually really hone this skill. I think it's one of those things that seems to be true, but it's not quite enough for us to postulate it. It's going to have to be a theorem, and it's easier for us to prove once we understand more about triangles and the angle-side relationship. But until then, so right now, I'm going to take this guy and I have this point C. And this guy's going to be perpendicular through point D, okay? And again, the shortest distance, and we're going to just refer to that as the distance, right? Because there's, I don't know, we'd want a longer one, but the shortest distance from C to line AB is on the perpendicular line. So let's work in a coordinate plane, okay? I'm going to show you guys here what we're going to wind up doing. Construct a coordinate plane. We're at the x and y axes, and we're going to take line AB, which is going to be 4, 5, 6, 1, 2, 3. Going to be negative 6, 3, and that's point A. And then we're going to have 6, negative 3. 1, 2, 3, 4, 5, 6. Okay. Moreover, we're going to have negative 4, 2, which is on this line, okay? And this is point D. And then we're going to have negative 1, up 1, 2, 3, 4, 5, 6, 7, 8. C, which is negative 1, 8. And this distance is perpendicular. Okay? So the directions are find the distance from point C to line AB. Well, that's literally just going to be the distance here. Gentlemen, you keep hearing distance, and I hope that you are recalling our favorite formula, which is the distance formula, right? Let's recall what the distance formula is. It's going to be equal to big square root y sub 1 minus y sub 2 squared plus x sub 1 minus x sub 2 squared. Remember, this is a rather forgiving formula. We try not to freestyle when we do mathematics, right? We can't just switch x and y in whatever order we want them to, but as long as you take that difference and square it, it's pretty forgiving, and you're going to wind up getting the correct answer. So take the big square root, right? So the y's minus the x's, so I'm going to say 8, oops, getting ahead of myself, 8 minus 2, which is going to be 6, squared, plus negative 1 minus minus 4, right? And that's going to be squared. So we're going to get square root of 6 squared plus 3 squared, right? Because negative 1 plus 4 is going to be 3. And 6 squared is 36. 3 squared is 9. So the sum of those is going to be rad 45. Okay? Now we know we don't want to punch that into a calculator. That's silliness. But we do need to reduce that. Remember, that is the same thing as 9 times 5, right? For 45, and we can 9 is a square number, so this is going to be 3 rad 5. All right? So make sure that we leave our answer just like that. Do not punch that into a calculator. Okay, just a couple more examples for today. So we've already done some constructions. Just real quick, remember that we need to remember a few constructions that are going to happen on our quiz. Remember the corresponding Engels postulate. It's the construction where we copy an angle. That's from lesson 3.3. Also, we're going to remember the perpendicular bisector. That's the construction that we just did before I started this video. Okay, and again, you can find that construction on page 149. And I might try to make a video of it, me doing the construction, showing you guys with the compass. Okay, so let's do a proof. A, B, and C. This guy's a right angle. Okay. These two lines are parallel. We're going to number these 1, 2, 3, 4, 5, 6, 7, and 8. Our given is that AB is parallel to B, and that A is perpendicular to C. And we're going to prove B is perpendicular to C. All right, so here we go. 2-column proof. Left is statements, the right is reasons. Step 1, we're going to restate that A parallel to B and that A is perpendicular to C, and that's because that is given. Now, remember here, if we have parallel lines, then those corresponding angles 2 and 6 are going to have to be congruent, okay? Moreover, if those guys are going to be congruent, then this is actually a rather short proof, okay? The textbook, when it performs this proof, really goes about this in a funny fashion, that it actually goes and proves 2 and 3 congruent through vertical angles, then saying that 3 and 6 are going to be congruent, right? Because of alternate interiors when you have those parallels. But we actually know just from the get-go, angle 2 is going to be congruent to angle 6. And that's because of the corresponding angles postulate. We can make that conclusion because A and B are parallel. Now that 2 and 6 are congruent, you know that angle 2 is equal to 90 degrees, right? And the reason we know that is because of the definition of perpendiculars or of right angles, right? Is that it creates right angles. So then we could say the measure of angle 6 is also equal to 90. Why? Well, if 2 is congruent to 6 and 2 is equal to 90, then 6 is also equal to 90 because of the transitive property. Right? Not technically that substitution. It's like a 3-part substitution here. If that's the case and 6 is equal to 90, then line B has to be perpendicular to C. This is the definition of perpendiculars again. It's pretty straightforward. Remember, if I have perpendiculars already, right, with 2 lines, as we proved in class, then those lines have to be parallel, right? It's a number of things. If nothing else, it's going to be for this reason, which is that corresponding angles are going to be congruent. So this will actually create the parallels. So if I don't have A and B marked parallel, but I had A and C perpendicular and B and C perpendicular, then those lines would have to be parallel as well. So that's pretty much it. That's all I've got for you for today. Please complete your lesson 3.4. Good luck.